for the survey is $100. All right, let's move on to question number 6. Question number 6 is also a pretty straightforward one as well. In this case, we have perfect information already. We've already paid for it. So what do we expect profits to be? This is the expected value with perfect information. Remember, this is not the expected value of what's the expected value of the sample information or the perfect information. That's of. Now with the information, this is how much we're going to make if we do have the information. The example up here, our expected value with the survey is $29.45. And the expected value in this case is going to be the probability times the best case scenario in any one of these states of nature. So 0.7 times our best possible value, which is 34, is 23.8. And we'll add that to 0.1 times our best value here, which is 3.2. And we have 0.1 here times our best case, which is 30, which is 0.3. I'm sorry, which is 3. In this case, it was 3.2 and 3. And now we have 0.1 times our best case, which is 10. And that would be 1. So we're going to add our 23.8 to our 3.2 to our 3.0 to our 1.0, and we come up with an expected value of 31.0. Again, we're not coming up with the expected value of the perfect information. We want to know the expected value of the strategies we would choose if we had perfect information. All right, and I can quickly pop over to Excel and do that one real quick. So let's say that our best scenario under State of Nature 1 was 34. Our best option under State of Nature 2 was 32. Our best option under State of Nature 3 was 30. Our best option under State of Nature 4 was 10. And any of these could be the team that you're playing, and this could be the number of points that you're scoring. And if you knew exactly what plays to run against that team, this might be the expected outcome of those games. And let's say this is 0.7, 0.1, 0.1, oops, and 0.1. And these are our probabilities, and these are the best cases. These aren't from one row. These are from the rows that have the best cases in these rows. The 34, 32, 30, and 10. And we'll now simply multiply these together. I'm going to just copy that formula, and we'll add those up. And we come up with a value of 31. It should take just a few moments, may not even need to use a calculator for a problem like that. And let's move on to question number 7. All right, question number 7 is a conditional probability question. And this one's a little more tricky, but if you think about how you would set it up, we're just going to use the same tables that we've used, same types of tables that we've used in many of these other problems. In fact, if you look at the table right below, we're going to set up a table very similar in this case. This is a joint probability table. These are conditional probabilities. The probability of B happening given A1, that's a conditional probability. So we'll set up a conditional probability table, and you should see it's pretty easy to solve this one if we just set up the table and just draw it out. So we'll go over here to our friend Excel, and we'll just set up a conditional probability table. So in our conditional probability table, we're going to have our A1, just like all these other tables that we've seen, our A2, our A3, and across the top we'll have B1, B2, B3. Now in a conditional probability table, you'll remember that the rows are all going to add up to 1. So we'll go ahead and put a 1 out beside each one of these. In a joint probability table, you remember that the cells, all the cells together are going to add up to 1. So in a joint probability table, all of these cells together add up to 1. In a conditional probability, they're going to add up to 1 just across the rows, like this. Okay. So in our problem, we've been given the probabilities. If we see right here, we have what's the probability of B1 given A1? That's going to be 0.2. So B1 given A1. So where would that go? So let's take a look at our other table. So B1 given A1. So we have A1 here and B1. That's going to be our point 2. And let's center all these so it's easier to read. There we go. So B1 given A2. Let's go back here. Now we have B1. That was B1 given A1. B1 given A2 is 0.6. B1 given A3 is 0.1. Now they're not always going to be. These could all be jumbled up. These could be jumbled up and you should still be able to do it. Let's go to B2 given A1. B2 given A1 is 0.5. B3 given A2. So B2 given A3. B2 given A3 is 0.6. And we have B3 given A2. B3 given A2. I guess we need to add a B3 out here. So B3 given A2 is 0.2. And we finally have B3 given A1. B3 given A1 is 0.3. That's right here. And let's see here. We've got all right, so we've got our A1 and B1. Okay, we have all of those values. We have our B2 value. Oh, that's what I did. I counted that one again. Let's get rid of that column. That's what's messing me up. There we go. So we have, in this case, we have our 0.2, 0.5, and 0.3. Again, let's look at where those came from. This is B1 given A1. B1 given A1 is our 0.2. B1 given A2 is right here as our 0.6. B1 given A3 is right here. Remember, we're just setting this table up. And we have B2 given A1. B2 given A1 is here. B3 given A2 is right here. And B2 given A3. B2 given A3 is down here. It's our 0.6. And then finally, we have our B3 given A1. B3 given A1 is up here. Now you're going to see that we don't even need these guys because these all have to add up to 1. So we have all those. Now what are we missing here? What would it take to make this equal 1? We have 6, 7, 8, so we'd have to have 0.2 there. 0.2. And what would we have to have here? 6, 7, we have to have 0.3. So now we filled in the blanks. Now what are they asking for in the problem? They're asking for B3 given A3. B3 given A3 is 0.3. So the answer to this whole problem is 0.3. We're just filling in the blanks. All right, that's a conditional probability table.